Hello and welcome to AI101, a no-nonsense guide to artificial intelligence. You can read all about me on my website rnanda.com. In this brief video, I'll talk about what is the difference between a base versus fine-tuned versus retrained model. There's another earlier video I have where I talk about when to use which one, but there was some feedback and people wanted me to explain the difference between the three, hence this video. If you already know how AI models get developed, you would know that the three key components of creating a base or a foundational or pre-trained, different terms for the same meaning. The three components are data, neural architecture, and deep learning algorithm. You can watch my video on MDLC, model development lifecycle, that explains these steps in much further details. So once you have a base model or a foundational model, then you have two options. One is to extend its learning to a new data set or to improve its predictions for a specific data set, which is called fine-tuning of the model. So this fine-tuning happens on a much smaller data set than the original data set that the model was trained on. The other option you have is you can use or retrain the base model on brand new data set for new type of predictions. And we'll give some examples in the subsequent slides. Of the three, creating a base model is the most expensive proposition. Retraining is the second one, and the cheapest option is to fine-tune an existing base model. So this is relative. It's not that a base model will always cost you millions of dollars. It does depend on the scope and the data and everything else. There are models that you can literally create for much less money if the scope is relatively small. So let's say you want to create a model to predict home sale prices. You get the historical data, which is generalized and normalized across, let's say, a country or a large region or multiple states, cities, whatever. So when you create that model, that we will call it a base model, is trained on data that is normalized and makes predictions around home sales. So when you will ask it, okay, what would be the expected home sale price for a different home, let's say your home, then it should be able to predict that home sale price fairly accurately. The challenge becomes because it is trained on very generalized data, the prediction may or may not be as accurate as you want it to be. So it may predict maybe 70% of the time it is accurate, or sometimes maybe 60%. It depends a lot on the training and the data sets and the quality of many other things. But now let's say you specialize in selling in a particular city or a state of the country. You want to fine tune that model so that its predictions are improved than what it does today based on the original training. So this is where the fine tuning comes in. So if you are a real estate broker, let's say in San Francisco, and now you want to use this model, the base model, but you want to make sure that the predictions that you give to your customers are 90% accurate, then you will need to take the data for that specific city like San Francisco and fine tune the model on that specific data set. And you will see a drastic improvement in your the predictions of the model. But now let's say that you like the quality of the predictions that the model is taking, and you want to use that in a very different domain. That is, you want to predict sale prices of electronic goods. So this is where you will retrain the model on this humongous data set, of the electronic products. And now the base model, you will have a brand new base model which will make predictions around electronic products. So this is where the difference is, that you uh, when you fine tune on this within the same domain and the same type of predictions. You retrain to make similar predictions but of a different domain. So that's where the subtle difference becomes. Let's take a little more practical example that everyone may be able to relate to. So let's say you want to hire a person, an HR person in your company. So you hire a fresh graduate who has earned a degree, MBA or whatever in HR, or you hire an experienced candidate who has worked in HR domain with other companies. So that is your similar to like a base model. Even though you hire the person, even the person comes with a lot of experience from the outside, you will still need to train the person on your company specific policies and procedures. So this is where the fine tuning comes in. But now let's say the person has worked with the company for 3-4 years and now wants to do something different and moves into supply chain group. So now this person will have to be trained or retrained on the policies and procedures of supply chain. So this is where a retraining comes in. The difference being in AI model would be that the AI model, if a base model is not trained on a totally new domain, it will forget and it will become very bad at predicting for the domain it was originally trained on. So it is called, if you have seen my earlier videos, I talk about catastrophic forgetting. So in AI models, catastrophic forgetting happens. And I put a caveat here that human beings actually build on cross-function knowledge. So that's a subtle difference. Don't assume that the person who shifts from HR to supply chain will forget everything around HR. I hope this makes it a little more clearer in terms of what the base model is, what is fine tuning and what is retraining of the base model. There are a couple of important considerations that you want to keep. You want to fine tune a base model when the pre-training aligns to your target domain. The examples like I've been giving in terms of the home sale prices, right? So let's say you want to fine tune that model into commercial real estate. Or like we said, let's say the original training was on US data. Now you want to, fine tune the model for India or Australia or some other country. But you are using the same domain and you are trying to make similar predictions. So the domain doesn't changes, the type of predictions don't change. The retraining of an existing base model would be where the domain may change, but the predictions will not. So the example up here I give is, let's say a base model that is trained on car sales now is retrained on home appliances sales. So the kind of predictions it is making is very similar, but the domain is now different. So this is the balancing act that you will have to think of when to fine tune and when to retrain. I hope this video helped you understand the difference between foundational versus fine-tuned and retained models, and when to use which approach. This goes hand in hand with the other video I created on the same topic. If you would like me to explain other concepts, feel free to email me. My email is on the website, or leave a comment on this channel. Thank you.